let's do this. Let me erase that. Let's do another one. So expand. So write down expand in your notes. Let's go with log base 7 of RST. Alright, so go ahead and rewrite that one real fast. It'll take about a minute because I'm running out of video space. So just write down your thoughts. Make sure you don't forget the what as you rewrite everything. Good, don't write the base. Alright, and if you're watching in the next class, right now it's really creepy. If you're looking at me, you should be practicing this one. How many logs do you end up with? Three. And they all have base what? 7. So the only thing that's going to be different in each one of these, right, we know they're our plus, is our, what's this guy called again?
Arguments.
The arguments, right? So the first argument is R,
S, T.
that easy. Right? Cool. And I'm going to give you a shortcut right now. Let me make this one look, might look a little harder, but let me make sure we understand our properties. So log base 9 of xy over z. Alright, so remember the properties you just copied down. Whenever we have division, what did that do to our sign?
Negative.
Subtraction, right? So which one had the subtraction sign in front of it? The bottom, right? So I can kind of just fast forward here, and the only one, when I separate all these into 3 arguments, right? When I separate them, which one of the logs is going to have the minus sign in front?
7.
The z, right? Because it's the only argument that's in the denominator. So this turns into log base 9 of x, and then what? Plus, because the next one's in the numerator, log base 9 of y, and the last piece is what? Minus. Log base 9 of z. So just make sure that's clear in your notes. Whatever is in the denominator has that minus sign in front, and the negative never goes in front of the argument. So that sign always stays in front of the log, because that's what the definition tells us.
So, do we put parentheses around the positive ones, just because it's separate from the z? It's not, because,
So all this,
yeah.
like, is one term. Like, all this comes as a package. I can't ever separate them, because what happens, and I don't know if this is your question, but people sometimes think later on, even in calculus, like, oh, this is log base 9 times x. No, but it's log base 9 of x. Once I start putting numbers in here, this all represents one number. Like, this comes as a package. So the parentheses, the only time I'm going to use them later on is when the argument becomes longer. So once I throw in like x plus 5, that is the argument, then I'll put parentheses. And we'll get into that shortly. Cool, thank you. Okay, here's a reminder. So as these get more complicated, don't forget everything we've learned in the past. Right? You can't forget everything we talked about in the past. So a reminder is, instead of writing the square root of x, that's the same thing as x to what power? What's that? Not 2. That's x to the 1/2, right? 1 over 2. And whenever I have the cube root of x, 1/3. Alright, so that's going to come, we're going to need that for these properties as well. Alright, so let's get another property down. Call it our power rule for logs. So we'll go with log base b of x to the p. So let's say that our argument now has an exponent. So what this property allows us to do is it allows us to bring this exponent to the front, and this exponent becomes a coefficient of that log. So this is equivalent to P, and if you want to put the dot right, times log base B of x. So these two are exactly the same. Alright, so what's this gonna do for us? Okay. And whenever you're expanding logs, you never want an exponent. So if you have this exponent, always bring it to the front. Okay, because we're trying to expand these logarithms. Alright, so let's take a look. Let's do an example with this. Alright, let's go with log of A times the cube root of B all over C D to the fourth power. And I want to expand this. I'll let me write that down. I want to expand. Alright, so when we expand this, what would probably be helpful is if I, instead of writing the cube root of B, I write it as B to what power? 1/3. So let me rewrite this. So this is the same thing as log of A times B to the 1/3 power over C times D to the 4th. Alright, so make sure you're able to rewrite that. Well, how many logs am I going to have here when I expand them? 4, because I have 4 terms there. Well, not really terms, but we can think about it that way. Right? They're going to expand into 4. So the ones that are positive are always going to be the ones in the numerator at the top. Good. So I have log of A plus log base B to the 1/3. What's my next sign? Minus, because it's in the denominator. Good. Log of C minus log of D to the 4th. So every single one of these, right?
Do we have to write the base as 10 or no?
No, you can, but it's understood. So what's the last step here? What can I do with those exponents according to my property? Good, we bring them to the front. So then this just becomes log base A plus 1/3 log of B minus log of C minus 4 log of D. And there's nothing else that we could do. So this is how we expand logs. So just like we could expand logs, we could also condense them, and that's the last thing we're going to look at here. It's condensing logs. So again, just a reminder, I'm just showing you these properties of logs and how to use them, but ultimately we're going to be using all these properties so we could solve logarithmic equations. Alright, so right now we're just developing these skills. So condensing logs. So here we go. Let's go with this. So log, throw some numbers in here because we haven't really used numbers. Of 216 minus log base 3 of 2 minus log base 3 of 4. Alright, a lot of different ways of doing this. A lot of different ways. Let's just use our definition that we had earlier. So according to our definition, we want to make sure that these logs have the same what? Base. Do they?
Yeah.
Cool. So what I'm going to do is I could turn this on to one logarithm. So log base 3, what's going to be in my numerator? What's upstairs? 216. Right. And downstairs, what am I going to have downstairs? the 2 times the 4. How do I know that both of these are down here? Good, they both have that negative sign in front. So make sure that's clear in your notes. The reason they're down is because they have that negative sign in front. Alright, so now we could simplify this. Log base 3 of 216 over 8. So do me that favor. Go ahead and divide those two. 216 divided by 8. And I think we get 27. And so now, we're just asking ourselves, 3 raised to what power gives me 27? 3 raised to what power gives me 27? To the third. So that's just 3. Alright, let's do another one. So again, we want to condense these logs. Questions before I go on?
So if there's no positive argument, do we just put 1 over and then just write the argument from down? So let's say there was no positive one, like 216.
Oh, say or negative.
Yeah.
Oh, good question. For our arguments, the arguments always have to be greater than 0. And in our definition for logs, we're gonna see that the argument has to be greater than 0, because if I were to make that log base 3 of negative 216 and I punch it into my calculator, I'll get an error. And I'll show you that. Actually, let me just show it to you right now. It's a good question. So let's say we have, I'm trying to figure out log of base 3 of negative 9. Say I'm trying to figure this out, right? We could go back and use our definition. So I don't know what this equals. So here what I'm trying to do is I say 3 raised to what power gives me negative 9? Well, wait a minute. Is there any exponent, that any number I could put there that would result in a negative answer? No, because even if I use negative numbers, what does that do to the outcome? It doesn't make them negative, it turns it into a what? The positive, but what type of number? A fraction, right? So there's no way that I will have, so for x, there would be no solution. Right? And the reason, so that's why our argument always has to be greater than 0. So the argument is always greater than 0. Great question. All right. And that comes up in that video, but again, in that video with the graph, it's hard to do what we just said using numbers. So, good job. All right. Let's do this. Let's mix it up a little bit. Let's go with 5, and I want to condense this. 5 log base 7 of x minus 9 log base 7 of y plus log base 7 of z. And I want to condense this. Instead of writing all these different logs, then, what's that? Oh, it's time? Oh, this will be the last example, thank you. So let me do this quickly. These become the what?
The exponent.
Exponents. So this becomes log base 7 of x to the 5th minus log base 7 of y to the 9th plus log base 7 of z. Which one of these is going to go to the denominator? Because that was a negative one, right? Alright, cool. So, a lot of properties, lots to talk about on Monday. I'll see you guys Monday. Thank you. What time?